Okay, let's get started. So this is, I guess, the second lecture for the iPhone class. We're switching gears. Okay, so last time, or maybe it's the second or third, I'm not sure. Last time we should have talked about Objective-C and built some Hello World stuff. And I may have shown you the command line prompt. So today I'll show you in Xcode how to create packages, how to run command line tools with Objective-C, for those of you who insist upon using it for that purpose. And then we'll start in our first couple of iPhone applications today. And so I have some PowerPoints, and then so the way I'm gonna run this one as well as the next class, as well as the Android classes, I'm trying to split it out, some PowerPoints and then some examples. And then the more the examples I can show you, the better. And we start small and we work up big to bigger applications. So, and I'm working on getting all these examples out like, zipped up and packaged and labeled correctly. So it's work in progress. So let's see what's going on here. So this one is officially lecture number 2, and it talks about writing initializers. In lecture number 1, we talked about the base language. The concept of the initializer is the focus of this lecture. In terms of, a correct initializer must comply with, and what do we have here? We have the initializer name that should begin with init, and the initializer that returns the initialized object itself, or self. And the initializer calls the initializer of the superclass. So it's kind of very similar to Android, actually. This will propagate up the chain of inheritance until we get to finally to the init, the initializer of the NS object. Because if you remember, even though we're using inheritance with a first object that we created, as we saw last week, we inherit actually from NS object, which is the highest object in the hierarchy. So it's kind of like in Java where we inherit from object, but we don't actually have to say object. In C++, we don't have to say object either, but in Objective-C, we actually have to explicitly inherit from NS object. And the initializer also uses the value returned by the superclasses in it. So when we run a super to go back up to the superclasses initialization, we take that return value and we use it in the current initializer in it. And the initializer must consider and correctly handle the construction errors, any errors that might exist. So that's our initializers in terms of some keynotes related to that. Now we have some keynotes related to method syntax. And what I'm going to do is kind of hit you with several different sort of a review. So we've sort of seen this last time, but to refresh your memory. The definition is preceded by that plus or the minus, and it gives us the return type as a C minus cast. So minus float results. So we have float as a cast to the return type of result for the method, and it's minus. So then preceded plus or minus and the return type as a C cast. If the method has no parameters in the definition, the call consists only of the method name, and each parameter, and we know that this is class and instance methods, the pluses and the minuses, hopefully remembering from last time. And each parameter is represented by an a colon, as we've seen in the previous syntax from last week, followed by a parameter type as in a CCast. So here we have colon integer, which is take this parameter 1, par 1, cast as an integer, use as a parameter for method number 1. So it's just following the parameter name, we have that colon, and then we have another colon, we have another colon, we have another colon, like in this example here. So before each colon, one can put a label. The labels become part of the method name. So compare the two definitions below. We have the float sum that takes on A, B, and C, and it takes and creates a sum. And then we have the float sum of A, and B, and C. So the red part is the label that's being referred to. If you put the label there, it's a little bit more self-expressive, but not required. Put the label there, but you can put the label there. Here's some more examples in terms of the definition. So here's our float sum. Our method, the return type is a float. The method name is sum. We have A, B, and C. Returns A plus B plus C. And then here's the syntax for object 1. Sum 1 is 1, 2 is 2, 3 is 3. So point 1, point 2, point 3, actually. And we have another one here. It's the same thing as sum of A, sum of B, sum of C, returning A plus B plus C. And we've got the sum of, the sum of, the sum of repeated. So the two methods are pretty much doing the same thing, but the second one reads much easier than the first one. Some might disagree. I actually think the first one reads easier than the second one, but we'll see. So read the detailed explanations in the lecture notes. I'm going to have a lecture note in a form of a doc file, and this I'm going to be putting up probably tomorrow. If you haven't noticed, the iPhone Behacker site is pretty empty right now, so I'm in the process of getting organized, and I've been kind of busy lately, so I've been a little behind. However, we're going to have what's called lecture notes, and the lecture notes are going to be PowerPoint and doc files, and so I'm going to upload those, and I've got one I'm going to show you when I get done with this lecture. That is a doc file that goes over a couple of examples that I'm going to go over as well. So let's continue with the initializers. Initializers with arguments is an example from the class Hello World. We have initialize with a number n and a value v. These are labels put on the parameters. Number n, value v, return self. So the big difference is the return self at the end here, and the return type of ID up here at the top. And this is called dynamic typing in terms of the concept. So the ID is the same as a void asterisk in C, which is basically saying that we're not really returning anything. So now I can write IDHW equals hello world alloc, and I'm going to go over alloc actually, the memory part of this in a separate lecture as well today to review, to give you some more pointers on that. And then in it with number 3 and value 3, excuse me, 3.7 is going to be passed to us. So the initializer is much better, but still not totally correct, but it's on the road becoming a little bit more feature-rich. So the call to alloc returns a new object, and we looked at alloc last week as well. So to this object we can send it init by sending the inherited init to the parent class. So the initializer should continue only if this init succeeds. So we could put a check in there to see here if not self is equal to super init. If it doesn't succeed, if it doesn't get anything back, then we're not going to return. Otherwise we're going to return nil. Otherwise, we're going to go ahead and say self number is n, self value is v, and then return self. Now basically letting us know that the other object is around and it returned correctly. So the whole call becomes more complicated, but it's explained in the lecture as well. So there's an example of it in the lecture notes. So here's a new class. So we have the @interface student, and as I was mentioning before, we have the :ns object. That we're inheriting from NS object, which we actually have to put in there, which is interesting. And we have a string object name, and then a float GPA, and then we have ID init, the initializer, and then we have init student with it's going to take on the parameter of the name. So, and this is a cast to say that name is going to be of a string type. So it's a float, actually, excuse me, a pointer string type. And then float for the GPA as well, and then an end. So that was a kind of a review of the class structure in terms of what that looks like. And here's the student class, okay, class student, and an implementation. This is an interface. So the implementation is of the student, and this is the interfaces. So this is the .h and this is the .c++ file, or the .h and the .m. We'll use Objective-C. So the .m would actually have the implementation of the method, and here's the body that we just looked at in terms of the previous examples for the initialization. And then for the init student with the name and the GPA, we would take and copy the name and the GPA and then return self. So pretty much the implementation of this. And they call it an interface instead of a specification, because it really is defining the interface to the class in terms of the .h. Behavior that's associated with that. So as promised, it was a really quick lecture. And what I've got actually that I'm going to post along with that lecture on the bhacker.com site is a doc file. And the doc file is going to be called lecture2.doc. And this particular file, once it comes up, is going to be associated with it, but it's going to have a lot more reading because I don't have a book for this course, and so instead I'm going to provide documentation in terms of examples and things. So this is 5 pages long, and it's going to go through an example of the interface and the implementation for a class, as we just saw a few minutes ago. And then a program here that's going to be a Hello World. In fact, I think we've gone through, we may not have gone through Hello World yet, but we're going to go through something else today. It's going to be very similar. So. And then some external, some additional reading, essentially, on the concepts. So I will post that out there on the website along with the PowerPoint that I just went through to give you some additional reading. So this next lecture is number 3, and it's very short. It's like 4 slides long. And, so I have like 3 little short lectures today, and some source code examples. I may have had that loaded already. I don't know. So this was on derivation and runtime binding. So derivation and runtime binding are most essential parts of object-oriented programming. What do I mean by derivation? Well, it's inheritance. So to derive one class from another. So it's a semantical mechanism for inheritance. And we've seen before it's that colon and then space and then the next object. We don't actually put excess methods associated with it. It's assumed to be public. And the inheritance is semantic derivation. It expresses the meaning of the derivation. So the derivation is the mechanism by which the class acquires the methods and the instance variables of the other class. It's called its superclasses. So same concepts that apply in other object-oriented languages apply in Objective-C, where we have subclasses that have superclasses, and a subclass can be a superclass, and a superclass can be a subclass. And essentially, we have an entire hierarchy of classes. Inheritance is expressed in new classes in terms of its interface declaration, and here it is. Here we have interface grad student colon student. So this is the inheritance part of it, and that's very C-like, or C++-like, except for there's no access methods. So in C++, we'd see grad student colon public student or something, and we never see NS object on there either. We never see from object, but everybody's inherited from something in this language. So. Additional instance variables can be added along with the ones that are automatically inherited, and it's the same concept as C++ again. All of the instance methods and all of the instance variables are inherited. So the list of inherited methods to override can also be done. You can override and overload just the same way as you can with C++. So here's a list of designated initializers for grad students. So init grad student, and this is the same function we looked at before, essentially. Repeated, essentially, to override. So grad student is going to override students init method. In terms of runtime binding, this is the interesting part. So we can have multiple versions of these functions that override each other, and then when the program is actually executed and running is when the binding is going to occur. So the decision during the runtime which method to execute when the message is sent to the object is determined at runtime. So the executed message depends on the type of the object that's being performed. And the message can be sent through the typeless pointer ID as well. So ID is actually that interesting concept that we talked about last week. It is typeless. It's kind of an interesting concept. Especially when Objective-C came from C++ that was very type. I mean, it was very strict. It was a strongly typed language. So now we have typeless Objective-C. But Objective-C isn't C++. It's better. So. Alright, so the next lecture is it's not a PowerPoint, it's actually a PDF file. And I couldn't get it converted to a PowerPoint. I figured, why not? We'll just leave it alone. It's in the concept of garbage collection, which is kind of an interesting, because what I'm going to do each week is give you a little bit about Objective-C in terms of programming, and then give you a little bit about the iPhone interface, and then the features, just like sort of like what I'm doing with the Android class, except we're not doing as much Java programming in that class because there's an assumption that most people are familiar with Java, but most people aren't really familiar with Objective-C from a certain point. So from an iPhone perspective, memory management is an interesting concept because there's no garbage collection. So we've seen alloc being used to allocate object space. So when we don't have garbage collection, this means that the memory is not automatically freed up. as in the opposite of the Android system. We do have garbage collection. So when an object is no longer in use, the object is no longer pointed to by some pointer variable, it turns into garbage. So a lot of people, especially if you come from a Java generation, you've never heard of garbage. It's when you allocate an object and you don't deallocate it, and it's still out there and still occupying resources, but nobody's using it anymore. So every time you allocate an object, you got to free it up and release it from memory to make room for more objects that are running. If you write programs that don't do that, you're going to have write programs that are crash the iPhone and no one's going to use your program, essentially. So the programmer must be careful to free memory when the object is no longer in use. So we have the methods to do this, so retain, release, and deallocate. So retain is actually a word we've seen already. Release we've seen. Dealloc. And alloc is to allocate. So dealloc would be to deallocate. So every object that is a block of memory that stores its data itself, one part of the block is available called the retain count. So the record of the number of pointers with the access to that block is kept, and then you keep track of the number of reference pointers, and you know if something is actually using it, something's not using it, then you can deallocate it. And here's a concept, unfortunately this sort of overlapped it, it should be moved up a little bit. But we're looking at the two blocks that are associated with each object, and then here we have the retain. Retain count value is equal to 2. So in this particular example there are 2 pointers to the object memory, and retain count is 2. So the method retain and release affect the value of the retain count. So when something gets released, it might turn up being 1, and then it's going to be 0. So the method dealloc is automatically called when the retain count reaches 0, and dealloc causes memory to be released. So when there's no count, dealloc, if I'm saying that correctly, will automatically run. So it's not considered garbage collection though. So the whole point of using retain and release is to keep the retain count accurate. So if you don't use release, the retain count doesn't, and it's an automatic counter that's kept within the object to keep track of references to the object's memory. If you don't use release, or you don't use retain, the count gets out of sync. So if you don't want to retain and you don't release it, then you'll never make it to 0. If you don't make it to 0, dealloc isn't going to perform. So dealloc is something that's performed automatically by the runtime environment when the retain count value is actually equal to 0. So any method that begins with alloc new or contains the word copy allocates memory blocks for an object and sets the retain count to 1. The retain method increments the retain count by 1. The release, so the retain means hold it, increase it by 1. Release is the one that's going to get rid of it. Removes, decrements it by 1. So every time you release, at the end of the code of the method, it will change the counter, and you modify the counter, and keep the counter up to date, and then you can actually remove your object when it's no longer being used, and not remove it before while it's still being used, essentially. So here's an example. The front door view controller, my front door, is equal to a front door controller alloc. So this is allocating a new object of front door view controller. So the block of memory for front door view controller is allocated and the retain count is set to 1. So, and then we retain and release in the setter and getter methods, so to set information to get information. The @property directive contains the attributes, so one of them is frequently retain. So @property non-atomic comma retain means hold on to it, or actually increment it by 1. Means something is using it. So the retain increment tells the compiler to write the setter function to retain any objects that it assigns. In terms of the instance of this TV show is an example of this object. So the correct way to allocate memory for the TV show is by following this particular example here where we've got a mutable array that we're setting an array. We haven't actually talked about arrays yet, but we've, and maybe we did in the last lecture, I'm not sure. We have another lecture coming up with arrays in it though. So in this mutable array, which is an array that can grow, it's not set to a bound, static bound limit, alloc, which is allocated. So in it with capacity 1, And then self TV show is going to be equal to my array, and then my array release gets rid of it. So the point is that we've released it after we've alloced it. And so most of the examples are going to use this sort of format. And we've actually seen a couple already with the release in it. So statement 1 allocates the memory block and sets the recount to 1. Statement number 2, this one right here, assigns the pointer to the memory block to the instance of the variable TV shows. And because the setter method for TV shows executes a retain, the retain counter is incremented. So now it's equal to 2. And then statement number 3 releases the memory, decrements it back down to 1. So it actually hasn't been released yet because it was set to 2 with the second line of code. So when the program is done with TV shows, it will execute a release itself. So the program itself is still using it, even though that one part of it, the one method, may not be using it. So this will decrement the counter back down to 0. And once it's 0, then the memory will be freed automatically with a dealloc. So typically occurs in a dealloc method for the class, so we can have avoid dealloc to deallocate it. So TV show release. This is a particular code that would be put inside of the dealloc method. And that would be run to release the memory, and then call super dealloc to release anything that the called inherited object may have also be holding on to. So it also happens if a new assignment is made to TV shows. So we can see the implementation of it a little bit below here. The incorrect way to allocate memory for the TV shows is as follows, where we have a self.tvshows equals, and we have a mutable array alloc that we're using to allocate. So the alloc method of statement number 1 allocates the memory block and sets the retainer count to 1. The assignment of the pointer block to TV shows. Because the setter method also executes a retain, so the setter method here is going to actually do it automatically for us. We didn't actually have to call alloc. So the retain is now 2 instead of 1, since there's no release following this. So if we put a release in there, then we can put it back to 1, which is where we want it. So see, no existing pointer in memory. So if there's no, when we create garbage like this and it's not released, and we don't create, during the class of the dealloc, the retain count will decrement to 1. If it's decremented to 1 and it's still out there, it's not released. If it's not released and there's no pointer actually pointing to it, it's what's called a memory leak. So it's the same term used in other programming languages. It's because the available memory is getting smaller and smaller. It's leaking away. So here's the implementation of a setter method as discussed above, where we're going to retain. And because we're using the retain in here, we have to do a release in order to get the counter down. So property non-atomic retain tree class tree. We have a setter, which is going to be set tree as an example. We're going to say it's of type tree class. And if the tree class is equal to tree, then release, otherwise retain. So if tree is equal to new tree, retain it, keep it, essentially. So in statement number 2 here, it releases the current value of tree. So the release of the reassignment mentioned above is corrected. So, and then also, I'm not going to read the rest of it. You may download this. It's going to be called iPhone memory. But in terms of the implementation of the getter method, the setter and the getter, so to get it, you're going to return tree. So it's an auto release. So to get it, you're not really allocating anything. To set something, you are allocating. So usually, because you're creating an instance of an object, you're setting a variable, you're running a method. To get something, you're not doing anything. So it's an auto release. So alternative to a release, auto release, you can actually put down on the bottom. Instead of immediately decrementing the return counter to 1, auto release marks the memory for later retain count decrements by adding the block to the auto release pool, and then when the auto release performs, it will automatically perform any release of any memory that was held by that object. So. The rest of this kind of goes to the example of avoiding cyclical retains, where one object is going to retain something and then it's retained by another object, and it runs essentially in a kind of sort of a linked cycle. Then you'll never release anything, essentially, if something is always retaining it. And then when you have a cyclical structure, I sort of think of it as more like a tree concept. If the tree is running in a circle, you're never going to get to the end. It's never going to release. So, and you can run through the example on your own, but I just wanted to essentially give you some few more notes on the concept of garbage collection and how that's handled. As long as you remember it's handled through that reference counter, and the reference counter has to be decremented. So your operations should be either performing a retain or a release, depending upon the functionality that's needed. And hopefully you're releasing down to 0 so that the object can be deallocated. Otherwise it holds up memory, and the memory is not going to be used very efficiently because it's going to cause a memory leak. So that was Garbage Collection 101 for the iPhone. And not the same case in other programming languages, so it's just kind of interesting to see how that's done in the iPhone. So let's go and look at Xcode. And Xcode we have, hopefully everybody has installed. And I have discovered that I can load the more current version on this computer, which I'm probably going to do in the near future, upgrade it. I'm still working on the older version, the 3.2.6, the 4 point something works just fine. But I'm afraid to upload it. I'm afraid to upgrade, but I'm going to have to. So, because every time I upgrade, something goes wrong. So I figure it's safe this week. Perhaps next week I'll be on the more newer 4.2 or whatever it is, the newest version. But they're both essentially the same. I mean, for the purposes of what we're doing the first couple weeks, it's the same. So what I did is I loaded in week number 1 and week number 2 examples. The week number 1 example was showing you, and we did this at a command console. And we typed in the GCC compiler, and I'm not sure if I actually showed you this or not. I did not. But if you wanted to run this in Xcode, you would create. In fact, let me just go here. New project. You click on New Project instead of going into an existing one, which I did a few minutes ago. And if you want to run a command line application, which is not bad. When you're starting to get familiar with Objective-C, it's nice to be able to test out methods and things without having to worry about the iPhone and the interface to it. And you click on the Applications under the OS X menu, and you go into Command Line Tool, and you click on Choose, and you give it a name. It will create a command line console-based application for you. And when you do that, what you get is, let me go back actually, back to week 1. You get, in this particular case, I put together the example that we looked at last week with computerscience.h, which was our interface class, and our computerscience.m, which was our implementation class. And you can see, actually let me make it a little bit bigger here. You can see the kind of sample code. This is what, if you missed last week, this is what we went over in terms of the syntax of Objective-C. And we see we have some instance variables, and we have some member functions that are associated with it. The return types are all void, and the minus is that they're all instances. They're not class level methods, they're instance methods, which is what you're going to be writing most of the time. And it takes on, and we have set undergrad and we have post undergrad, which are going to be 2 methods. And this is the specification or our interface, and our implementation is in the .m file. And just review that concept. And this is basically going to provide the method bodies for each one of the methods that we have in our interface, in our .h file. Slightly different, and this concept holds true for all of the iPhone development, which is why I'm kind of focusing on this in the beginning, because then students get wrapped up with iPhone stuff, GUI stuff, and then they forget there's a .h, there's a .m for everything. We're going to see that today when we build our first iPhone application. It's not going to be Hello World, it's going to be a better one. So we've already done Hello World. And if you haven't, there's a YouTube video that does it for you. It's a pretty elaborate one. It takes user input and stuff too. So we have our class object that gets created with a combination of these 2 files, and then we have main, and main is our driver program, and I just double-clicked on that to show you that it opens up in its own window. And hopefully I'll be able to get back to that. But the main driver program is just like any other main program that we have in C or C++. And you can kind of see where we're using release here to get rid of memory, and we're using alloc up here. Here we go, allocate the memory, and we're creating a pointer to an object. Same as C++, there's a lot of similarities in there. And this is the implementation. In fact, we're doing an alloc on an auto release pool created as well. We're initializing, here's our initializer here, and then we're applying the method to the instance with 120. It's going to be set to it. We're applying a parameter 2000 to it, and then we're printing the information to the screen, running that method, and then we're going to release the memory, and then we're going to do a pool grain to really release the pool of the resources that we've allocated for this application. And one thing I wanted to show you today, actually, how do I close this, actually? I didn't want to double click on it because now I can't figure out how to close it. We got that on the bottom now. Well, if we clicked on build and run, what ends up, I don't see the screen anymore. We'll see on the bottom where it says success. And oh, here we go, it's back here. The overlaying screens are kind of confusing. I actually ran it from here. But what we should see is a couple of different options for viewing the output. And this is the interesting thing. In most other command line kind of interfaces, we see a command line window pop up. So we can actually open that up ourselves. If we go into run and then we see console. So if you go into the run menu, this is kind of weird because you'd think it would be in the window menu, but it isn't actually. So if you go into the run menu in here, console, here's the output actually of that program that I just ran a few minutes ago, where I set the number of students, the total number of students. Actually, the output for the program is the total number of students is 2120. But the window's sort of hidden, actually. The other thing you might do as well, and you look at the targets, and you'll see that this here is the executable that's built. And so if I go into the executable, one of them is going to be the builds. Nope, I don't see it here actually. But under the target, I should be able to also find the, or if I go out into the, products, I'm sorry, I'm in the wrong directory here, products. This is the executable file. If I double click on it, it shows me, it runs, and it shows me the product of the command line console as well. This is actually all of the output of that program right there, so because it's a command line interface. But the tricky thing is you actually have to bring up the command line prompt yourself. So it's not really tricky, it's just hidden, I should say. So the other example that we did this on the command console last week using the terminal window in GCC. It was another one that actually used, I think I called it example 2. I believe I also have it in here too, so we'll take a look at that in Xcode. It is example 2. And example 2 was very similar. It just had students, so you might start to get the impression here that all of these programs sort of look the same, and they sort of do. So we have student.h, and student.h is, look at that, it's using a type-defined structure. That's a C++ code. So example 2 is using C++. So as I mentioned before, you don't like Objective-C, you can actually use C++. In fact, you can write C++ code in iPhone applications as well. In fact, you can write both Objective-C and C++ together. But as we're going to see today, it's probably better to stick with Objective-C in terms of writing those application interfaces. But this looks like C code. And this looks like C code. In fact, it's got a .c next to it. But I'm going to run it, and I've got the project set to command console for the Apple interface for application type. And I don't have to really explain the C code to you. Most of you are familiar with printf and scanf and stuff. We've got main up here. Main's going to have a, regular old C code. So now if I run this, it's not going to tell me, I'm sorry, you're running C code. Instead, it's going to say succeeded. And then if I go into the run menu and I look at the command console, lo and behold, I see my output. So this one was hard set to Greg and 3.90 as his GPA. So it only created a student. Actually, you can see the code down here. Created the structure was initialized. It created a student and with a GPA. It was Greg at 3.9 as a float, and then it printed it out. So Greg 3.9. So you can kind of see that you can run C code. So you can also use the command line interface and compile things by hand using the GCC compiler, including the framework. If you include the framework, then you can write a command line console application that works on a MacBook instead of a PC, essentially. Same thing, same C you get, but you're writing it through Xcode and you're compiling programs for the Mac. So this next example I'm going to show you is what I call the first of the iPhone applications. And so I sort of kind of went searching around to begin with to like, where do I find something that, you know, a tutorial. And then I thought, well, maybe I'll put one together. I'm like, well, why do I want to reinvent the wheel? So I went out looking to see, you know, who's got some good stuff out there, you know, who's willing to share it, you know, kind of thing. And I found, and unfortunately these links I've discovered don't work, but I found this nice website that I'm going to give you the URL for, that video will be live. Oh, very good. Looks like my video completed. Let me find this bookmark here. Here it is here. So if you write down the URL, it says Ray, the guy's name is Ray Wenderlich. I'm probably butchering it. 1797, I'll make this a little bit bigger. If you look at this YouTube video, actually pause it and write down the URL, you can go back and look it up. Because there's more than just this one tutorial I'm going to introduce you to. And I like the tutorial because it goes through Model View Controller. And I can tell by the style of his programming that he does traditional object-oriented programming, and which is kind of the purpose of this class, is to learn Model View Controller, iPhone. You know, it's not just to build applications, it's to learn the foundation of what the architecture is and what you're working with in terms of the object-oriented components as well. So anyway, the iPhone app tutorial part 1, the tutorial actually uses, and the reason why I'm showing this to you is to not only give credit where credit is due, but to also introduce you to his website and the fact that there's a lot more other really good tutorials here. He puts together how to create simple iPhone applet tutorial in 3 parts. And today I'm going to go through part number 1. And I'm going to go through it because I'm going to talk through a lot of this stuff in terms of the Model View Controller, which I immediately noticed from him and went, oh, this is really nice. This is because you rarely see this. You usually just see, you know, stupid tutorials where they don't actually explain concepts to you. So I put this in a PDF file just to make it easier and to break it out. You know, so just in case you don't have internet access, you can download this file and do it on any computer. And I'll make this available at the bhacker.com website, or maybe I'll just put this underneath the YouTube video somehow. But anyway, it's building this bug program. So we're going to build part 1. Actually, I have all 3 parts built, so I know that it works actually. But I want to talk through the reasoning behind everything that we're doing here. So it makes a little bit more sense. So I had to create a simple iPhone app tutorial part 1. I'm going to kind of skip through his introduction. You can read through it on your own. He goes through, you know, his little background and why he wants to do it. But you can read through that. What this is going to do, what this app is going to show you is you know, obviously getting started with iPhone development. It's a little bit more than a hello world. But to store your app data in a model, which is the data model that we're going to create. And then look at the view, which is the table view that we're going to create for this. So table views, including adding and deleting rows in a table view, which is kind of interesting. And then creating a detailed view for the row, supporting both portrait and landscape orientations in the app. Navigational controls, and image pickers, use of the controls, the text fields, the buttons, the image view. So there's a lot of stuff going on. This is a pretty rich example. Icons, default images, stuff of that nature. How to build long-running operations. So you know how to, you know, if you're going to put this out into the iPhone store, how to make it so it does its garbage collection and it runs, and you know, has a little bit of, you know, debugging stuff inside of it and stuff like that. And you may also read through the beginning. I'm going to assume that you have your Xcode installed and you've got your stuff ready to go. So let's talk about Model View Controller, MVC. View is like the interface component to your application. So you can, this is a design methodology, model view controller, and it comes from the original object-oriented days. And it starts out with these three angles or perspectives of the application. So the view is its interface, its control mechanism. So every application has a control. And this actually sort of loosely applies towards the Android, but not really. It's more applied toward, and Objective-C is a true object-oriented language and environment, and we're really working closer to that object-oriented world with the iPhone development. But long story short, we're going to use a view that's associated with, and this is kind of an interesting example. This is why I love this tutorial. These are three different applications that are out there that are using the same sort of view interface. And the view interface is a list box. It's a table view. Or it's something similar to this concept here. In fact, if you start looking at it, even your email programs, your text messaging programs, or look up an image. So we're going to start with this using a common control. So common controls for the iPhone. The table view. So you've probably seen a table view in a lot of different apps. Here's some examples. And we're going to define this view in terms of our interface. Then we're going to create a model for the data and use it in a model category. And then we're going to have a controller category that's going to control the data through the view, which is interesting. And then we're going to link it together. And there's three parts to this. So the beginning part of it, which we're going to run today, and the next week we'll finish 2 and 3, because I won't have to explain very much of the rest of it to you. It's kind of a get you started on iPhone development, because we haven't really done any of this yet outside of Hello World. So the first thing we're going to need to do is create a new project. And the new project that we're going to create is going to be in Xcode. It's going to be under the iPhone OS, and we're going to create what's called a navigation-based application. Not a command console, not an application, but a navigation-based. So I'm going to kind of show you what that means. So if you go create new Xcode project, and before I was down here with command line interface. I'm going to go back up here, and I'm going to select application, not library, but application, and then I'm going to see navigation based. So if I pick choose, I don't have to actually worry about the data storage, because our application isn't going to store data. It's not going to store persistent data. So it's going to download it, use it, or get it off of a web. Actually, it will store data, but it will be in the application itself. It's not going to download data or put data in. The third part will, and I'll explain a little bit about how you do that. We don't have to worry about clicking that button in there. So press choose, put in a name, and you're going to get, let's find part 1 here. You're going to get a basic application that's started. And I say, rather than watching me type, what I'm going to do is kind of show you the steps, but I've already put it together, because part of it was also proof of concept, like, is this actually going to work? So, just to make sure the tutorial was good. So when we do this, here's got a little screenshot here, shows the navigation base. Looks pretty much the same as mine, a little older API, so it's okay though. Name the project Scary Bugs, which is what I did. Click on Save, which is what I did. Check out to see what we've seen so far. What we can do actually at this point is, not a bad idea actually, after you've created the blanket project, is to run it. So if you run it, you're going to click on Build and Run, and when you run it, you're going to get the Hello World application. This is the finished application, so this one's going to look different than what you're going to get, but interesting. I should get a menu showing up. Oh, it's thinking. Here it goes. Okay, good. It's actually pulling something from the internet, so that's why there's a little bit of. Actually, no, I shouldn't say that. It's not pulling anything from the internet. There's a bug in this program that's fixed in part 3 that makes it load a little faster, but because of garbage collection, which we haven't seen yet. So the application that you're going to see is going to say Hello World on the top of it, though. It's going to be a base application, but make sure the application actually runs first. That way you know that you've got a good working project and you have a good install of Xcode. So one of the first things that we're going to do is find the tutorial. Here it is in the background. So make sure it runs, follow through the simulator, and it should look like this actually, because it's just not going to have anything in it. It's just going to be a blank application. So what you're going to see is a working project. From the start, this is going to be a navigational-based template, which looks like that. And some of the other templates actually say "Hello World" or something on them, but this isn't going to say anything because it's navigation-based. Navigation-based is menu-driven. So navigation is going to give us, by default, the ability to put a table view or a list box or something there that's going to allow us to pick and to press on stuff in terms of a GUI interface. So we're not going to dig into the template that's being used for the navigation. I would save that for reading, actually. So you can read up navigation-based and see everything that's associated with that. So scary, so that is actually the definition of the view, which is going to be, a navigational-based view. So the next part of it is really the model in terms of the organization. So the model in terms of the data hierarchy. So now the hierarchy of the folders, the groups, and everything. By default, it looks like this. We have classes, other sources, resources, which is what we get in any other application that we load up. In fact, a couple of them that I showed you so far had classes in there. We've got our corresponding classes that are associated with it. So it comes with several different groups, classes, other sources, resources. We can actually change these groups to better organize our efforts. And if we change them, we're just going to organize things a little bit differently to give us more of a model. So first we want to rename the existing group that's called classes. We're going to rename it view controllers. That would be up here, because what we have is actually the controllers and the app delegate up here, which is really nothing more than the controllers. So if we go back out here, I'm just getting over a cold, so my voice is not what I call best today. So here's the view controllers. I've renamed this already, but this used to be called classes. And you just right mouse click and you hit rename, and you can rename it. Why am I doing it? Well, because we're creating a model view controller, so which is why we're going through this right now to organize it this way. Because what we have is the controller for the app here, and the controller, and you see it has a .h and a .m, a .h and a .m. We're going to keep this consistent in terms of our sets of files. So we rename classes. Now we have controllers, and now what we're going to do is we're going to we're going to create the model. So the model actually isn't there, so we're going to have to add a new group. And when we add a new group, we're going to call it model, and that's where we're going to put the classes that we're going to create for our data model. Because what we get by default is the controller. So if we come up over here, we can say add new group, and then we can call the group. I already have it. I'm just going to call this model 2, and then so I can remove it. But that's how we got model out here. And then in model, we're going to create these files, and we create the files, and this is kind of a tutorial on Xcode today, by the way. So we're going to begin, so we're going to organize things this way. We're going to have scary bugs data, scary bugs doc. Because what we're doing is we're modeling the data and the functionality of the system. So we're going to add that class. We'd have that in here. So the data contains the bug name and the ratings. That is going to be the data. So okay, so scary bugs, just to tell you, is a program that's going to keep track of different types of bugs. And the bug information, well, I don't think it really has a description. There's a name and there's a picture of each one of the bugs. And then in step 1, we're creating the list of the bugs. In step 2, we're going to put the rating system in there to rate the bugs, so we can keep track of which one's more scary than other bugs. And we can actually put this rating system on a server and share the information, so there can be a global rating of which bugs is the most scariest. And then in the third part, we optimize it. We do a little bit of speed control in terms of the way that things open up. And I believe we also added an option to edit the bugs and to create new bugs, add new bugs into it. So it increases in functionality, and eventually what you have is a pretty nice bug program. So what could this be? This could be an address book. Here's the concept. And what could be an address book of? Well, what we're going to do later on, hopefully, if I can figure out how to put the example together, you can take pictures from your phone And those pictures of the phone can show up instead of the bug pictures, along with the name of the person and their telephone number. And then we could, okay, I guess we could rate the people too, I guess. Rate our friendship with them. I don't know. Add people to it, take people away, keep track of addresses, telephone numbers, information about them. And it's actually kind of a common model of an application for a phone device in terms of a collection of data. So the view is the list and the hierarchy. The data is the model. It's the pictures, it's the description of the pictures, the information we want to keep, and then the controller is the addition, subtraction of the pictures or the bugs or the people, and then the editing of it and the control of the application from a perspective. So every single application out there follows through model view controller. If you think about it, you can break down every single application, object-oriented application. You have objects that take care of each one of these different parts of this model. And it's considered a design model. It's a design model in theory. So, okay, back to the application here. So in terms of our model, we're going to have the bug data, which will keep track of the name and the rating, and the bug doc, which contains a full-size image, a thumbnail image, a scary bug data. So it's the doc that's going to keep track of the stuff associated with the bug. So the reason why we're setting this up is that we might want to make things easier in a follow-up. So if we build it this way, then we can, if we keep this all separated out and kind of keep these components in mind, it's easily extendable, as we're going to see. We're going to build on it in 2 more revisions. So we can start saving our data to the disk, implement sharing, do all sorts of different things to it because the model is extendable. So the scary data model implementation, not too hard. So I'll run through on this data number to model 2 directory so you can see how these components fit together. We're just going to add some new files to it. So we can right click on the model group and select add new under the iPhone OS. We're going to choose the Coca touch class, then Objective C, and then make sure that the subclass of NS object is selected, and then click on next. So this is what the screen looks like. And if I go out here and just do it, under Model 2, I'm going to go add new file, and I'm going to select Coca Touch, which was selected by default up here, and Objective C class, and then I'm going to make sure NS object is on here. And then I'm going to click next. And then in the next I'm going to give it a name, and in the name that it wants me to give it is going to be on here. So the name is going to be Scary Bugs. Scary, I wonder if I can cut and paste this. Copy, let's see. Scarybugs.h. And there we go. And then also create the scarybug.mh is underneath it, if you can see the, because they know you're going to create them in sets. So if you do the .m, then it will create the .h. So I wonder if I do h in here, will it say .m? No. So just curious. Then the location is going to be under scary bugs. Perfect. So I'm going to go finish. And the template file already exists, so I'm going to cancel it because I don't want to overwrite it because I already cut and pasted and put everything in there. So I'm going to say cancel. Perfect. Basically you do that and you get scarybug.m and scarybug.h. And you have to do that again for scarybugdoc and scarybug.h. Well, you're only creating it once essentially. And what he's done, and this is not what I would call a programming tutorial. How we're going to populate these classes is by cutting and pasting the code and putting it into the class. So that's why I said it's nice. I liked it because it was getting through model view controller. So getting through the concept of it's kind of a nice application building approach for someone who's new at mobile phone development. So what do we got down here? This is what the finished product looks like. We got scarybugs.h, and we've got do it again, and we'll get scarybugs.data class as well. And replace the scarybug.h file with this. So what we're doing now, and as I was mentioning before, which is why I kind of just pre-populated this ahead of time, The scarybug.data, the .h file, this is the code here, although in his tutorial it's kind of more wrapped together, so I kind of made it look better here. But it's the interface, as you can see, and it's inherited from NSObject. So this is the same type of programming that we've been looking at so far. And we have a string called a title, and we have a float called a rating that we're going to use. So this is basically two instance variables for each one of the bugs that we're going to create. We're going to have a title and a rating. And then we have a property for which is going to be a copy of the object, which is going to have a string title and then a float rating. It's going to be used as properties that are going to be set for the particular items. And then we're going to have an init with title. We're going to have a rating that's associated with it, method for init ID. So if I go back, I will also make this available via the website. So you can kind of see it's the same code, but it's kind of word wrapped. He sort of goes through an explanation of it, but not much. So don't rely upon it. Don't rely upon this tutorial as an Objective-C programming lesson. It's more of a cut and paste kind of thing. So you're doing the same thing for the scarybug.am, and you'll see that the scarybug.am is just an implementation. Scarybug.am, here we go. Scarybug.am has got a few new things to synthesize. I'm going to get into that next week, actually. So I'll save that for right now. But we have the method body implementation, because this is the .am that's going on. And we're actually deallocating. So we have that, remember from the lecture I gave you earlier on a few minutes ago on the memory management. This is the use of that sample method to deallocate, which is going to do a title release and then a super deallocate, which is exactly from the example I gave you earlier in terms of that explanation of the garbage, creating your own garbage collection, essentially. He doesn't actually go through any of that. And then creating the doc, the document file, nothing in particular to note. It's about the same. Replacing the .m code with that code, .h code here, .m code with this code here. And let's see. That one is in here, so nothing, it's just really just the same type of code over again, except for this one's keeping track of the data and the thumbnail, the thumb image, I should call it. The full image, the thumb image, the data that's associated with the image in terms of the scarybug data. And what we're going to see is that in terms of resources, I put what do we got, logo 1, I got different images. These are bug images that I've downloaded from his website, actually. And you can take, in fact, if you go to the website, I believe you can probably download the completed project as well. Whether the project's going to work in the current API might actually just come up here and change the release to what it's supposed to be. And I believe it would probably work just fine. But you actually just download this stuff and you just drag it into this, from the desktop you drag it in. You can see how the resources actually get populated. Oh yeah, I was going to show you something else here. So in this example here, the scarybug.h and the scarybug.m, it's just keeping track of the resources, the bugs. So it's the doc information about the name and the bug and the image that's associated with the bug that we're going to be using here. And we've got the deallocate method as well to take away all of the garbage that we've created through the alloc above here. After we get done adding those two classes in there, and this is for our model, we go back to the controller and we look at the root view controller.h and we add a couple of things. In fact, what we're adding is the interface for, it's going to be an array. And the array we haven't looked at yet, but it's going to be, they call it a mutable array because it gives us the ability to grow. If you're familiar with C++ arrays, you say 10, 20. Well, what if you built an iPhone app that only had 10 and you had an add button? You reached your 10, the array can't grow. So it's a mutable array, so it can actually grow. And if we go, let me remove this actually, I don't need this one here. go into the view controllers. What we're really modifying is root view controller, M, and root view controller H, and we're essentially adding this array to keep track of the bugs. And the code that's in here is simply inserted. So make the following changes. So we're changing it after the interface. We're inside of the interface. After property retain, put this in here. So if you go through the instructions, he tells you where to put the lines in I'm probably in the wrong here. I am in the wrong one. Here it is. Mutable array bugs, to create mutable array bugs, which is going to be an array that's going to keep track. This is that line right here. Retain mutable array. And then in the .m file, putting the code in to work with the array. And let's see. Looking at the rest of it, I don't believe we've changed anything outside of I don't think the delegate actually gets modified in here, but you can change the portrait to landscape mode. And this example, the first part of it isn't actually using the interface browser. It's not using the GUI tool to actually put anything out there because it's just programmatically using the list, essentially, the list view. So you can put a title on each one of the bugs. So we're called title to the string of the scary bugs. And so title is a special built property for the viewer controllers. So when we navigate to the controller display to the view controller, it's going to show this title property for us. And the bugs are going to pop up. So if we look at the method inside the UI table view cell, we can set different properties as well. And what he's going through, and you can download this and read through it on your own, but what he's going through is making changes to the properties to set it. And in fact, I didn't leave it, I didn't do any of the changes. So it's going to be in portrait mode instead of landscape mode when it shows up on my phone. He's also got another tutorial here. This link does not work, but it's called a table view programming guide. It will show you all of the different table view properties that can be set so that you can populate it with data and create your own table views with, different types of properties that are set for different images and stuff. So in terms of the destination pictures, the scary bug pictures, the rest of it that I've kind of just skipped through a little bit was an explanation of the properties that can be set on the table view. So how do you get the pictures in? So as I mentioned before, you can go to this link if you go to the website, download the scary bug pictures. He found them actually at Stock Exchange. So they're not his bug pictures, but they're pictures that apparently hopefully he has permission to use. So, so once you've downloaded the pictures, you actually just drag and drop them, and you're going to get this little dialog that says, would you like to copy it into the destination folder or use the source? It's kind of like when you add music to like iTunes or something. Do you want me to copy the file or you just want to use the source file? I would recommend copying the files. That way you can reuse them in different projects. And, because once you delete the project, it deletes all the files that are associated with it. So copy them in. And then throw away the source if you don't want them anymore. So this is how you populate it. And what you're doing is you're populating out. I don't actually have to show you through his instruction. I can just show you. In fact, I did show you already. I showed you already. You're just dragging them in here. So you're taking them from the desktop and you're physically just dragging them in. Actually, I'm going to change the logo. So if I did that, I could go to here, take this take this icon here, and drag it into resources. And this is the screen where I was going to say copy it. So copy the item in there. So now I got icon, or what was it called? It was called icon. That's the ITU logo. So now I've got the logo in here, so I can use the logo instead of his logo for the copy. And actually where that comes in is you can set these resources as properties. As an example, I can come down here to under the products subdirectory, excuse me, at the end here, let me make this, what was it called, icon? Yeah, under here, I can say, I can add different things to it. As an example, if I come over here to the right and click on and say, I believe there's one that says icon file. And so yes, I want the icon file, and I can set the icon file to icon.png. It'll take it from my resource directory. So how we get the information is we add it into the resource directory, and then we can use it. So this is that logo that's going to work for the resource that I've set in this property for scarybug.info, which is going to give me my title. So I can set the title, call it, my Scarybug program, whatever, and use the icon here. And this is version build 1. It's going to show up in a window. So, when I recompile, it'll change it to that icon. So. And the resources are just something that you're going to have locally, so you don't have to specify a path or anything for that. Alright, so after I've added all the images in, you can open up the scarybug.delegate.m file, although we do have to make some changes, and we add this particular code in here at the beginning of the application start, and the delegate's going to tell us to open up. We're going to call a potato bug first, and then we're going to have a house centipede. So it's basically telling us what to load into that list view, and it's the application delegate, kind of like main. If you think about it to a certain perspective. Let me go back to that for a second. And this is what it's talking about here. So the app delegate, when it loads up, it's going to have a potato bug, house centipede, wolf spider, and ladybug. Are going to be the items. So it overrides the pointer from the application launch to put this stuff into that list view box that we're going to see on the screen. And then the rest of it is pretty much the same as the default. So we're just adding this code to populate the bugs. Here's our bugs. And then when we run it, the application should look like this. It just says scary bugs on the top. And then it has potato bug, house centipede, and ladybug. So if I run mine, it should essentially give me scary bugs. Yes, save everything. Hopefully I haven't made any typos. It does take a few minutes to load. I didn't change the title, but I can see that I've got potato bug, and nothing's going to happen because the functionality isn't there yet. So if I click on the items, in part 2 we're going to build the functionality for what happens in terms of that. But I should see, let's see, if I go back to the main menu, here it is, the ITU logo. So you can see that the logo changed. And that's version number 2 or 3 or something. That's another icon that's out there. So you can kind of see how I can use those resources. Anything that you put in here, in fact, let me go back to the resource concept for a second here. Close the simulator. Everything that you put in the resources directory here can be used for different things. Like that's his logo. That was my logo. There's a text file in here that's going to give us attributes, and the attributes are going to be something like, the location, maybe for more information about the bug. Come here and look for more information or something like that. There's also an XIB file in here. So what I'm going to do, if you want to go to the website, download the project, get the project loaded. In fact, let me just take a look real quick because I think that you can probably download the project already built. Hold on a second. If you can, that's probably the best thing. That way you don't have to retype it because he's really not going over the code anyway. What's on the website is the same thing. I just exported to that. Make it easier so you don't need an internet connection. I don't need an internet connection. And if you're going to cut and paste it, you might find this will be a little bit easier to cut and paste from. And here it is, sample project. Okay, so you can get the sample project, Scary Bugs 1, and if you click there, you can download the zip files for all of the 3 different versions of it. And not a bad kind of example in terms of looking at the model of the application design in terms of the design pattern. Actually, I want to call it a design pattern. So it kind of gives you the kind of fundamentals in terms of deciding on what type of control and what kind of view, stuff like that. So anyway, so next week we will continue with this bug example, and then what I want to do is, I haven't really shown you very much in terms of the programming aspects because we haven't really covered very much. So what I'm going to do is kind of have this fun stuff here and then mix it in with some Objective-C programming so we can actually write some source code to do certain things. And it's just going to be writing some methods to do some stupid stuff on the screen so that we can get familiar with how to write the source code. Because a lot of the examples that you're going to see out there are going to be here. Cut this, put it here. Cut this, put it here. You know, cut and paste kind of stuff, which really doesn't actually give. I mean, outside of the design component, which is nice to learn in the beginning. It's nice. Actually, I'm not discouraging you from using the cut and paste technique, because in the beginning, that's the way you're going to have to learn how to use all the interface tools and things that are, you know, get familiar with the environment. But after a while, you're going to be wanting to write your own stuff from scratch. So that's where having a little knowledge of Objective-C is going to help you. So I'm going to kind of mix it 50-50, some PowerPoint, some examples, and then for this particular class, it's going to be cut and paste examples and then some writing examples. So next time we're going to write some iPhone programming syntax ourselves and connect it with maybe just putting pictures or something out or doing something stupid, you know, something easy. So, questions, comments, or concerns? No? We're done for today then. I'll see you next week. And keep an eye on it. If you haven't subscribed to the YouTube site, I've been putting out miscellaneous stuff as I come through. Some miscellaneous video stuff. I don't know if I have anything recent for the iPhone class. I know I have stuff for the Android, but not much of the iPhone. But so sometimes I have some out-of-class stuff that I'll post up there, just because it's easier for me to post it up there than to explain it to you in class sometimes. All right, thanks for showing up. Sign the roster if you haven't signed the roster yet.